In question 10, part A, we have to use the identity for sine A plus B to prove that sine 2A is identical to 2 sine A cos A. Now this is the identity that we have to use. Sine A plus B is identical to sine A cos B plus cos A sine B. I'm going to write sine 2A as sine A plus A, and then just replace A here, because now this angle is also A, so this one becomes A, and this one also becomes A. So we have sine A cos A plus cos A sine A. So these two are the same, so we can just write them as 2 sine A cos A. And that's what we've done here. Now in part B, we have to differentiate this term, which is the natural log of tan half of x, and show that it equals cosec x. I'm going to do that by using the chain rule. The first thing that I did was let t equal tan half of x, and then let y equal the natural log of tan half of x, and then wrote y in terms of t, so y equals the natural log of t. Now I have to differentiate t with respect to x, so I will get dt over dx, and I have to differentiate y with respect to t, so it'll be dy over dt. Now when I multiply these two together, I get dy over dx. So dy over dx equals dy over dt multiplied by dt over dx. When these two cancel, we're left with dy over dx. That's what we want here. Now dy over dt is 1 over t, because the derivative of the natural log of t is 1 over t, and dt over dx is half sec squared half of x. Now here we have t as tan half of x. Now we're going to replace the t's here with tan half of x. Now we know the identity that tan x is identical to sine x over cos x, which means that 1 over tan x is identical to cos x over sine x, and that's what I wrote here. 1 over t as cos half of x over sine half of x. And sec squared x is basically the same as 1 over cos squared x. So I've written half times 1 over cos squared half of x. Half 1 over cos squared x. Now we have these two terms multiplying together, so we can cancel the cos half of x. So this one and this one cancels, and we're left with just 1 cos half of x. And when we multiply these, we're left with half, so it's 1 over 2, and then sine half of x and cos half of x multiplied together. Now, using the identity from part A, we know that when sine of an angle is multiplied by cos of an angle, and there's a 2, like 2 multiplied by sine of an angle multiplied by cos of an angle is identical to sine of 2 times that angle. So we have sine of 2 times half of x, which is just x, so 1 over sine of x, sine x. And this can also be written as cosec x. In part C, we have to, a curve C has the equation y equals the natural log of tan half of x minus 3 sine of x, and they've given us a range. Find the x-coordinates of the points on C where dy over dx equals 0. Give your answers to 3 decimal places. Okay, so let's see. So dy over dx is cosec x minus 3 cos x. Because the derivative of the first part, which is this, we found in part B, which is cosec x, and the derivative of 3 sine x is 3 cos x. So that's what I've written here. It's cosec x minus 3 cos x. Now dy over dx is 0, which means that cosec x minus 3 cos x is 0. Now I write this as 1 over sine x and add 3 cos x on both sides of the equation, so I get 1 over sine x equals 3 cos x. Now I multiplied both sides of the equation by sine x, so I'm left with 1 equals 3 cos x times sine x. Now here again, I'm going to use the identity from part A, but I have to make a few adjustments. So I'll multiply and divide this, the right hand side, by 2. So this I multiplied and here I divided, which does not make a difference because I'm just multiplying by 1 basically. So now I have 2 cos x sine x. Now this part, which is 2 cos x sine x, can be written as sine 2x, which is this. So 1 equals 3 over 2 sine 2x. Now I divided both sides by 3 over 2. So I have sine 2x equals 2/3. And then we're going to use the quadrant rule to find x. Basically, we draw a quadrant graph, which is a quadrant diagram. So we have A, S, T, C. So all the signs are positive here. I mean, all the functions are positive here, and only sine function is positive here. And here, as we see that sine 2 of x equals 2/3. So this is a positive term. So we know that the angle is in these two, here and here, because sine is positive in these two quadrants. And these two give us 2x. So 2x equals the inverse sine of 2/3, which is 0.729. And make sure that your calculator is in radians mode. I've also changed the limits because we have 2x and not x, so multiplied all of these by 2. 0 times 2 is 0, and x times 2 is 2x, and this is 2 pi. So we're going to work using these limits. So we got here 0.729, which means that this is 0.729, and then we know that this is pi. So I did pi minus 0.729. If this is 0.729, then this is also 0.729. So pi minus 0.729 will give me this part. Just a second, let me change the... Yeah. So now I got this by subtracting this part from pi, which is 2.411. Now dividing both of these by 2, which is, I divided 0.729 by 2 and divided 2.411 from 2, so I get 0.365 and 1.206 to 3 decimal places. I hope this makes sense and it helps you.